class about from the velocity and the accelerations. Today we will discuss about the scalar and the vector quantity. What is the scalar quantity and the vector quantity? The scalar quantity means what? A physical quantity which is described completely by its magnitude, but there is no any direction. In a scalar quantity, it has only a magnitude, but it has no any direction. It means that it has a mathematical value, like as the length. How much? 5 meter length, 6 meter length, 7 meter length, 7 meter distance. It means it has only its magnitude, but there is no any directions. So that is called what? Scalar quantity. This length, distance, time, temperature, volume, area, these all are the what? Scalar quantities. It means those physical quantities which is described completely by its magnitude, that is called what? A scalar quantity. The sum of the scalar quantity is always positive. Okay, one thing is considered, it has the sum of this scalar is always what? Positive. It has no any negative value. It is always in positive. It has always in mathematical value what? Positive. So it is maybe the added by the rule of simple algebra. I will give you the differences between in your notes also. So there is it is added to the rule of the simple algebra. Okay, like as the length, distance, time, temperature, these all are the what? Scalar quantities. What is scalar quantities? Those quantities which are described completely by its magnitude only, that is called what? Scalar quantity. Okay. Now vector quantity. What is the difference of vector quantity? Now vector quantity. What is the vector quantity? Of physical quantities which requires the both magnitude and the direction complete descriptions, that is called what? Vector quantity. In this vector quantity, it has a both magnitude as well as direction. Both equally. Suppose displacement. What is displacement? The distance between the initial point and the final direction. That is the displacement. It has means in their displacement it has the both P, Q, R. This is the length of the this and this. It is the required one. This is the displacement because it has the both. It has some mathematical value. Suppose this is a 4 and this is a 3. It is what? 5. It means that 5 is the magnitude and it has the some directions. So vector quantity, the displacement is what? Vector quantity. It has the both magnitude as well as the direction. It is added by the rule of vector algebra. यो के हुन्छ? Vector algebra बाट गरिन्छ. This is the rule of what? Vector algebra. Like as vector PQ is denoted by like PQ vector. Yes, it is denoted by the vector algebra. So there is a differences between the scalar quantity and the vector quantity. I will give you the differences in your pictures. You have to note it in your copy. Okay. What is the differences between the scalar quantity and the vector quantity? It is also the very important questions for your exam point of the view. So you have to prepare in your home. Okay, good morning students. This is the second day for velocity and acceleration. In previous class, you have studied about the concept about the rest and motion, yes or no, and reference point, speed. Okay, so today is the second day and today we will discuss about the distance. What is the distance? The actual length of the path which is covered by a moving irrespective of the direction, that is called what? Distance. It's called distance. Okay, here the actual path covered by a moving body. Here just I will show you example. The point from A car is moving to the point B. After that it moves to the C. After the C it moves to the D. After the D, E, F, G. In this way a body covers some distance. Now it means it can move. It can be moved and it is the distance covered by a body meter, 3 meter, 1 meter, 4 meter, 5 meter, 2 meter. Yes, and actual the distance covered by a body is how much now? 17 meter. It means the body is covered how much meter? 17 meter distance. Okay, here the distance is in which the body is moving is not the considered. In which direction it is not moving, that is not the considered. Okay, so this distance covered by a body is a scalar quantity. What is a scalar quantity? Those quantities which have only magnitude but no directions. It means that their direction is not considered. So it is called what? A scalar quantity. You have seen here picture. I already explained you about the body are moving in a directions. Yes, in a body is covering the distance. But here there is no any consider of the directions, so that this distance is called as what? Scalar quantity. What is that scalar quantity? Those quantities which have only magnitudes, magnitude what? Mathematical numeric value, like as what? 2 meter. This is the 2 meter what? This is magnitude. So in this way, what is that? The distance, it means the actual length of which is covered by a body, that is called what? Length. So, okay, now after the distance, the displacement. Okay, what is that displacement? Means the shortest distance between the initial and the final position of a moving body in a certain direction, that is called what? Displacement. It means you have seen here the picture. In this, the P, Q, R. Suppose a body is moving from P to Q and Q to R. It means when it's the position of initial position and this is the final position. Means the distance between the initial position and the final position, this is called what? Displacement. Here you have seen the body is moving from P to Q. Body is called, okay, listen, distance is covered. How much distance is covered? From PQ plus QR. Yes, it means PQ is covered 3 km plus 4 km, 7 km. What is distance covered? 7 km, but the displacement is covered how much? 5 km. But displacement covered, it means, now look this figure by the Pythagoras theorem. P and R is called to root over how much? PQ square plus QR square. Okay, here you will see that 3 km. Oh, sorry, no? 4. Okay, here 3 and 9 plus 16, it is called to how much? 25. It means 5 km. It means what is the displacement? Displacement is 5 km. Okay, here you have seen the displacement covered from, that is according to the Pythagoras theorem, PQ is root over PQ plus QR. Yes, that is a 3 square plus 4 square, 9 plus 16 is 25, and so what? 5 km. It means the displacement is 5 km, but the distance covered is what? 7 km. So it is a vector quantity because it has some sort of direction with its magnitude. What is that vector quantity? Those quantities which are both magnitude and the direction, that is called what? Vector quantity. So here we have seen that it has a magnitude also and some direction also. So displacement is called what? Vector quantity. Why the displacement is called vector quantity? Because it has the both magnitude and the direction too. Now it may be the positive, 0 and negative. It may be what? Positive also. It may be the 0 or it may be negative. Just I will show you now one thing. Here you will see. Okay, now let's see here. If the body is moving in a circular path, Suppose this is the initial position. Our body is moving in a circular path and reaches in the original position after one rotation. It completes one rotations and once again it reaches here. The distance covered of a moving body that is equal to the circumference of the circular path, that is 2 pi r. The distance is covered by the 2 pi r, but the displacement is what? 0. How it is? Our body is moving from this point, this initial position from A, and once again it reaches where? At the initial position, the same initial position. It means it covers the distance, but the displacement is what? 0. Here we have seen in this figure. What is the distance covered, but the displacement is what? 0. And in a circular path, our body is moving from one rotations from the initial position and once again reach to their same final position in the same. So its displacement is what? Its displacement is 0. So it may be the positive, negative, or the 0. Okay. Now next. Okay. Now let's talk about the velocity. What is the velocity? The rate of change in displacement of a moving body, that is called what? Velocity. It means, or we can generally define as, the velocity of a moving body can be defined as the distance covered by a body for a unit time in a fixed direction. Here we are discussing about the direction. In a fixed direction, it means it has the what? Magnitude and the direction. So it is what? So velocity is what? Vector quantity. Here it means the distance covered by a per unit time in a fixed direction. That is called what? Velocity. Or we can also define as the rate of change of displacement, because the displacement is a what? What quantity? It is a vector quantity. Yes or no? So this velocity is also the scalar quantity or vector quantity? Vector quantity, because it has the both magnitude as well as the directions. So the formula to calculate the velocity is displacement by the time taken. The shortest distance between two events, that is called what? Oh, the distance called. Okay. So here we are discussing about what is that? What is that? Velocity. Velocity is a scalar quantity or vector quantity. What is it? It is a vector quantity because it has a fixed direction. It means it has the mathematical value, that is the what? Magnitude, and it has both directions. So it is called what? It is a velocity is a vector quantity. Okay. Now we will discuss about the more. Okay, the average velocity. Okay. Now let's talk about the average velocity. What is that average velocity? The average velocity of a moving body can be defined as the arithmetic mean of initial and the final velocity over which the given period of time. It means the initial position and the final position, both. Then average we have also arithmetic mean means the initial and the what? Final. Both should be but and we have to, because here the two values, initial and the u stand for what? Initial velocity. And v is what? U is called initial velocity, whereas v is called what? Final velocity. It means initial velocity plus final velocity by 2. That is called what? Average velocity. Initial position and the final velocity, final position, that is what? That is what? And the time taken, time period of, that is called what? Average velocity. So we can easily calculate the average velocity is initial velocity plus final velocity by 2. Now relative velocity. What is that relative velocity? The relative velocity is defined as the velocity of moving body with respect to another moving body in a certain direction. Yes? Means relative means relation. It is between the two bodies. Two bodies are said to be the what? Relative velocity if they are moving in a certain direction. It may be in the same direction or it may be in what? Opposite direction. I will show you now what is the relative velocity. Okay, now in relative velocity, case number first. Okay. Now let's talk about the case number first. When two bodies are moving in opposite direction, suppose the two cars here A and B. A and B. Here are the two cars. One car is moving with 5 meters per second in each direction, whereas another car is moving from west direction, that is in 1 second. How much? 15 meters. It means the total distance covered is how much? 20 meters. What is the total distance covered? How much? 20 meters. In where? In 1 second. In 1 second. Means here let's consider as the car A and car moving with the opposite direction of car B. Here another car is moving with what? Car B. Means in opposite direction. With respect to car A, with respect to the car A, the car is in opposite direction because the car A is moving in east direction, whereas car B is moving in west direction. Okay, look at the carefully. Look the picture carefully. Car A is moving in east direction, whereas the car B is moving in where? In west direction. It means the total distance covered almost 20 meters in 1 second. Yes. So a moving body in opposite direction. Thus the velocity of the car A, B, velocity of car A, and opposite car B will be velocity of B. So the velocity of car A with respect to the velocity of B, the velocity of car A minus velocity of car B. It means B velocity of A is with respect to the velocity of B because now they are moving in opposite direction. B is the negative as it is moving in opposite direction. Okay, car B is moving in opposite direction. So here velocity of relative velocity of what? A respect to B, that is called to what? Velocity of A plus velocity of car B. Both should be added. It means take a short concept. When the two bodies are moving in opposite direction, then must be plus. What is plus? So we have to add it. In the first case, when the bodies are moving in opposite direction at that time, we have to add it. Okay? Now case number second. What is the case number second? Okay, now the second case. Okay, case number 2. When the two bodies are moving in the same direction, here we have to look carefully the picture. The two bodies, car A and the car B, they are moving in the same direction towards the east direction. Both cars are moving in a same direction with the same reference point in the same direction. Okay, but car A has 20 meters per second, car B is 5 meters per second. It means in 1 second, what is the distance between them are 5 meters. So here let us consider the two cars A and B are moving along in a straight road in a same direction. Both cars are moving in the same direction. Let the velocity of car A and another car B be velocity of B. Since they are in the same directions, it means that at that time, if the bodies are moving in the same direction, at that time we have to subtract it from the what? Velocity of car A to the velocity of car B. Velocity with respect to car A with respect to car B. Here we have to do the carefully well. What is the velocity of car A with respect to B? A respect to B. But when there will be the question B respect to A, suppose velocity of car B respect to A, at that time we have to write B respect to the velocity of B minus velocity of A in this way. Okay, so at that time we have to be careful. The initial after the 1 second, that is, so when the body are moving in the same direction, body are moving, the two bodies are moving in the same direction, at that time what we have to do? Subtract. But in another case we have seen that when the bodies are moving in opposite direction, at that time we have to add it. Okay, at that time we have to add it. After that, if the bodies are moving in the same direction with a different velocity, at that time we have to subtract it. So we have to also do their reference at that time. B respect to A, then velocity of minus B car B minus velocity of car A. If there will be the velocity of A in respect to B, then velocity of car A minus velocity of car B. Then we have to consider the focus in that way. Don't forget it, okay? In which conditions? If the bodies are moving in a opposite direction, at that time we have to add it. And if the bodies are moving in the same direction or different velocity, then we have to what? We have to subtract at that time. Okay? So don't forget this one. Note